All right, here we go. Effects of the um, effects on zeros and local maximums and minimums due to dilation and or translation. Um, and so what we've got going on here is that this is not a periodic function. This is going to be y equals f of x, and specifically this is going to be a cubic function. And you could hopefully still remember how to go through and find your cubic function. Remember, you'd have f of x is equal to a times your three factors, and you got your roots, so you could hopefully find those factors, and then you have a point you'd plug in for x and y and solve for a. So hopefully you still remember how to do that, and if not, go back to Unit 2 and study up on that. So, but that function, whatever you would find there, f of x is shown below, and again it has intercepts of -2, 0, 5, and it has a local minimum down here at 3, -5. So again, here's your root, and there's your local minimum at 3, -5. So where do the x-intercepts and local minimum occur on f of 3 times x? And so that's going to affect, remember, your shrinking horizontally. This is going to shrink it 1 over c, so 1/3. Everything that happened at 3 now will happen at 1. Everything that happened at 6 now happens at 2, and everything, you got all the fractions there as well. So what's happening at 5 now will happen at 5/3. It's all being compressed, and kind of graphically taking a look at that. 5, well, let's go. 5 will become 5/3, so that's going to be, let's see, 5/3. That's 1 and 2/3. So right here, there's your new root. 0, that's going to stay as a 0 root. Your your minimum right here, which happened at 3, will now happen at 1. Our maximum here at 1/2 will happen at 1/3. And your graph's going to look something like, and I'm just going to sketch very lightly, or very roughly, looks something like this. It's been compressed to 1/3 its size. And so where are those points going to change to? Well, we had one root at -2, so our new root is x equals -2 divided by 3. It's being divided by 3, and our one root that was at 0 is going to be 0 divided by 3, but that's just 0. That one doesn't actually move at all. X equals 0. And our last one, which was at x equals 5, is now at 5/3. Again, you can pause, rewind, whatnot, go back to that graph. There it is. And where does our local minimum occur? Well, it was at 3, 5, and that x value got compressed. It got divided by 3, and so our new minimum is at local minimum is at 1, comma, -5. The y value didn't change. The y values of those roots didn't change. Just the x values were divided by 3. All right. And next we have, where do the x-intercepts and local minimum occur on 3 times f of x? And so think through this. Well, this time this is going to take our, and again, pause and actually think through it rather than just waiting to watch the video. But this is going to affect our y values. So let's sketch that out. Everything that was happening at y equals 0 stays at y equals 0, but all of our outputs are going to be amplified, or sorry, not that's probably not the amplification is going to be multiplied by 3, and they're going to be stretched vertically by a factor of 3. So where it was at -1, 1, now it's at -1, 3. Where it was at 1, -2, now it's at 1, -6. It's all, and now 3, -5 is now 3, -15, quite a bit south of there. And so it's going to be just extended. It's been stretched. Actually, let me fix that. It's been stretched. So you go way down below. and then on up. It's been stretched by a factor of 3. So there we go. And again, the x values are all the same. Nothing's happened, nothing's changed on the x values. So our roots are all the same. X equals -2, and x equals 5, and x equals 0. Our local minimum, though, however, its x value is the same. Local min is at, so still at 3, but the y value has been multiplied by 3, so -15, 3, -15. All right, and lastly, where do the y-intercepts, or sorry, the x-intercepts and local minimum occur on f of x plus 3? And so we've got a horizontal translation moving the entire graph 3 to the left. So our h value is -3. And let's graph that. So every point that we had before has been shifted 3 to the left. So it was at -2, 0. Now it's at -5, 0. 0 becomes -3, 0. And 5, 0 becomes 2, 0. So our roots have all just been shifted to the left. Our maximum has gone 3 to the, has been shifted 3 to the left. I think I said 2. And now our minimum is shifted 3 to the left. Our maximums being shifted 3 to the left. The entire graph is just being shifted 1, 2, 3 points to the left, 3 units to the left. So it should be the exact same shape. No dilation is occurring here. It's just the exact same graph, just shifted 3 to the left. And if it was a -3, it'd be shifted 3 to the right. If you wanted to raise the entire graph by 3, we could have f of x plus 3, and that would lift the whole graph up 3 units, so on and so forth. But that's not what we have here. We have f of x plus 3. So let's answer that question. Again, everything's moving 3 to the left. So our previous root of -2, that's becoming x equals -5. It's been shifted 3 to the left, and 5 is now x equals 2, subtracting 3 from the x value, and 0 is becoming x equals -3. Again, just shifting everything 3 to the left. Our local minimum, likewise, oops, that was the amplified minimum, but it's being shifted 3 to the left, so it's going to be local minimum at 0, comma, and the y value is unchanged. So y is -5 on your local minimum. All right, hope that helped.